easy quiz, nothing to worry about. So it's like basically like everybody should get the full is what my expectation is. Any doubts on that? I think it looks good, no? Whatever we have studied so far, if you just go and pay attention to that, you should be good. You should be getting full marks, no confusion. Right. Like what is the assumption in a linear regression model, for example? I'll give you 4 choices. One of them will be correct. 3 will be incorrect. So it's straightforward thing. Nothing to worry about. Yeah. The whatever we're doing is all assignment. So you're clustering your random forest, and then the last one, which is the market basket analysis. Viva is not there. So that's why I'm doing the quiz. Quiz is a Viva only. So that's why no phones, no laptops allowed, and no online help required. That's as good as Viva only. So if I ask 10 question in the quiz, 10 question as a Viva is the same thing. But Viva is like, one at a time quizzes all of you will take in within 10 minutes, we are done. Always get the same question. Yeah. But you'll be sitting outside. Like in this area. Not here. Abhi's saying, okay, you're creating more and more logistical problems for me. You can stand and do it also. Huh? You can stand in a row, do it and then come back. Huh? Online guys will do it, but they will have a different paper where they will have a time pressure working against them. So you have 2 options. You can go with this, where I will give you 30 questions to be done in 5 minutes, or you have 10 questions to be done in 10 minutes if you are taking here. 10 questions, 10 minutes, of 30 questions, 5 minutes. 30 questions, 5 minutes. No, I'm saying 30 questions, 5 minutes. So you'll not have the time to search online. We will see people who are absent, then they will have to do some other things down the road. You may have to come and present your entire work. Who knows? Whatever we have done in the class, you may have to come and present the entire thing. We can do something like this. People who are conveniently absent without any reasons, you will have even bigger threshold to cross then. How many of you are excited now for the next class? All excitement. See, that's good. Yeah. Huh? I mean, by now I scare you more than it's that the test is really gonna be, right? So you're in good place. But if you want complete system based, then I can squeeze 30 questions and give you 5 minutes. Written is okay. So you will not have time to search for it. If you search, then you will miss out on the questions. So that we'll have to have a reward mechanism for the people who really know the answer. Or you can think more, 10 questions, 10 minutes. I'm okay with both format. 10 questions, 10 minutes without help. Everybody agrees? 30 questions in 5 minutes. In 5 minutes. Timer will be 5 minutes. That's what I'm saying. You have to go fast then. It will be rewarding for your accuracy then. So 1 minute, you'll have to address maybe 5 questions. So 5 minutes, 25 questions. 1 minute, 5 questions. Huh? No, let's do this then. Let's do this. 25 questions, 5 minutes. 1 minute, 5 questions you have to handle. So if you know what is not an assumption of linear regression, how long it's going to take you to read and reply? No, it will be like this only. It will be like this only. I think it will be easier if you guys go with the 5 minutes, 25 questions. Hmm? Online? Yeah, 25 questions, 5 minutes. Negative marking, I know, I mean, that will add a pressure on you. You have to guess correctly. So no negative marking. You read the question, either you know it or you don't know it. Tick, move on, tick, move on, tick, move on, like this. So let's do it that way. I'll give you 25 questions for the quiz. 5 minutes. Hmm? We'll see. No, so you just mark it, whatever you know. There is no negative marking. You mark it and go, mark it and go, mark it and go, like this. Rapid fire round. Online. 5 questions, 25 minutes. So you will know, you'll have no time to look elsewhere. Even if you just open your phone, 1 minute gone. No, we have agreed 5 minutes, 25 questions. I can read. Otherwise, I can go back. Time to next back, right? This means I will get the paper and if time same, we'll see. I mean, we'll do a relative ranking. We'll do a relative ranking, right? It's not going to be absolute percent. It's going to be percentile. So let's say whoever has got the best, it's like a JE, percentile based, right? We'll just use that one. Huh? Okay, let's move on with the topic as Anupam was suggesting. So you have seen this, no? People who buy this also, right? So you've seen this. People who watch this movie also watch this movie. You like get the recommendation on the products and services, right? So it's a recommendation engine. So what we know, so like, so what do you think? People who bought the bucket, what they're gonna buy? 100% right. Mug it is. How about let's click on one category. Let's say pressure cooker. What do you think? Huh? Pressure cooker. What do you think people will be buying with pressure cooker? Gas? Gas stove maybe? Hmm? Buy the gas stove, will buy the gas stove. So what do you think people will be buying after this? Any guesses? People who get guess this one correct? Huh? Oven. Gas, oven, scrubber. It is the tea pan to go along with this, and the induction cooktop. Yeah, so those are the things that we are buying, right? So you can see sometimes it's not very intuitive what people are going to buy, right? That's where this recommendation engine really comes in, which is a statistical way of seeing, if people have bought this, how many of those buy something which is either intuitive or non-intuitive, right? So I'll give you one more example. I think I was just researching while I was thinking about it. So let's close this one. Close this one also. Iron and iron stand is clear, right? So they will buy that. Any idea what will go with refrigerator? Stabilizer, extension cord, stand, cover. Okay. Any other guesses? Ice thing, right? Yeah. It's a TV. It can be opposite also. Let's, yeah, let's. Hmm? Just a second. Hmm? So it's frequently bought together. So people who buy this, they also buy TV, right? So we'll do the reverse also. You're saying something, Anupam? Not necessarily. So that's how basically we get to the point where we see strong recommendations come in. Yes, yes, absolutely. So we're not saying why that is happening. We're saying it is happening, right? The, why would you suggest something which is not, uh, which will not go together? That's a different category. So I'll show you again. So let's say laptops, right? So they cannot use frequently go together category. So let's click on that category, TV and appliances, large appliances. Okay. Uh, let's just type TV, for example, 43 inch, right? And let's go with this guy. So you have this TV, right? They will have all the different options they're suggesting and then frequently bought together. Then they are, so this is what? This is what we call as a, this is what we call as a cross sell. You're cross-selling the product. This is what we call as a upsell, where people who have bought this, they're suggesting you something bigger or something better. So let's say you went in and you were shopping for a touch iPhone, right? And you began your journey with, let's say, iPhone 13. They say people who viewed this also viewed this. So instead of buying iPhone 13, you bought iPhone 15, right? That's a upsell that the, uh-huh. It is a cross sell. Hmm? No, this is not upsell. This is cross sell. I mean, you're bundling, product bundling. You're bundling the product and you're selling together, right? This is what I'm saying. Like, when you came in with a certain ticket size. So, for example, you came in for 27,000 ticket size. I mean, you're looking at that, and then you go up to 37,000 also. You end up buying a Sony Bravia 43 inch, right? that is clearly a higher ticket size, and you can say this is I'm making you buy a higher ticket size product, right? Anyway, so the bottom line is that it is not random. If you do random, then you will lose more than you will gain from the customer's trust point of view. So I'm going to talk about what exactly it takes, right? So go ahead and read this article, which is the article number um, hmm? 42. Article number 42. Yes. Yeah. I mean, of course, there's a blended strategy, but I'm saying like, in general, a normal recommendation engine will figure out what your past behavior has been. So like, let's say, I mean, let's take an example, Netflix, right? When they say people who watch this also watch this, right? They're actually looking at the data, what people have watched, people who have similar profile, what they've watched, and then what movies they are watching next. That's how they will actually send you the right movies. Otherwise, let's say if I don't watch Tamil movie at all, and then suddenly Netflix is going berserk, right? And it's recommending one Tamil movie after another Tamil movie to me. What will be my reaction, right? Nothing against the meal, right? But I'm saying just in terms of like, just completely going off the recommendation, right? And that will be a very negative experience for me that, why are you recommending this? Or vice versa, that if I'm a very hardcore Tamil movie fan, and then suddenly you are recommending some Korean drama, for example, right? By the way, I have never watched any Korean drama, right? So suddenly if I get the recommendation for watching Korean drama, I will not necessarily be, happy with that recommendation. But if it says that because you have watched, XYZ movie, now I'm recommending this movie, that will be better recommendation for me, right? Now why they are recommending that? Because you may be a big fan of a particular actor, for example, right? Or you may be a big fan of a genre of the movie, right? So let's say you like horror movies, right? Or you like comedy movies, or you like action drama, right? Or you like the sci-fi. So they'll say, what exactly you like, and what you, and like meaning it's not like that you have rated, so it's also what movies you have completely finished end to end, right? So those are some of the things that they take your behavior and then use that behavior to make the recommendation. So it's all coming in because of the statistics that we're looking at. And the other way is like, let's say I'm getting to Netflix for the very first time. They don't have any history of me, that what movies I have watched in the past, right? How do you think they will recommend? Based on similar profiles. So, I mean, I don't have like, any history, but they know that RP is this age group. He lives in this area, and he has told us that it's like, he's a male and blah, blah, blah. And then based on that, they will start, which is called the cold start problem. You can start recommending based on certain behavioral traits. Once you start building the actual watching history, actual, like, the browsing history, then you can start making the recommendation. Like, I mean, I don't watch like a lot of Insta reels and stuff like that, but a lot of you guys do. So you'll see that based on what you're seeing, they will keep on recommending the same stuff over and over. There's some silly dance that you like, right? And then every time that silly dance will keep on coming up, right? I mean, those two steps will keep on coming until you're sick and tired of that, right? So, so that's how the recommendation engine really works, right? So it's observing your past history, and then basis that they are recommending things for you. Does that make sense, Ajit, or you're? Yeah, it might be happening sometimes, but most of the times in the usual normal time, it's basically coming in from the recommendation engine. Yeah. So there are many, many types of recommendation engine. We'll be talking about something simple, which is called the a priori, or there's another name. I'm forgetting that name. Let's look into this article for a moment. A priori, or market basket analysis, or the affinity analysis. These are the three names that go along with this, right? So a priori is basically nothing but a probabilistic denotion of something has happened a priori. And then based on that, post what events will be happening, right? So a priori is for that. Market basket analysis on association rules, right? So that's what basically it boils down to. So there are three concepts which are main ones. which I will explain you. So there is the first concept. You can read the article so that you have time to go through it later on in more details. So the first concept is the concept of support when we are building the rules. What does the support really mean? Out of the total transactions, how many transactions demonstrate that behavior, right? So let's say per day in vendor X, there are 1,000 transactions. How many of those 1,000 transactions this product will be bought? So let's just do some math and then it will become clear for you. So support for milk in this one. So I have some dummy data over here. So this is a transaction ID 1, 2, 3, 4, 5, 6. And we know these are the product categories: milk, bread, butter, beer, and diaper. So out of those total 5 transactions, how many transactions milk was bought? Anyone? 2. So the support for the milk will be 2 by 5 or 40%, right? So in this transaction database, the support for milk is 40%. Is that clear? Why do you think this is required intuitively? Yeah, you want to make sure that you're making a high volume recommendation to somebody, right? So when you are making that recommendation, you have certain volume on the basis that you're concluding that, right? So if it is only one person who has bought that, that one person could be really off the track, right? And that's not a representative. But if there are many, many people who have done that, many people who bought, going back to that example, 23-inch Samsung and 43-inch Samsung simultaneously, then that gives you much more stronger basis to do that recommendation, because I see there's a lot of people who are doing that versus only one person who has done it, right? So if one person has done it, I should not make that recommendation. If there are many people who are doing the same thing, then I have more confidence, statistical confidence in doing that. Support for bread. How many transactions are there? 5, and 3 transactions you can see over here. Bread has been bought. So the support for bread is 60%. Is that clear, folks? What is the support for butter and bread? Butter and bread. So when both butter and bread was bought together, butter and bread bought together. So here, nope, here, nope. Only one transaction where the butter and bread both were bought together. So the support for the butter and bread is 20%, right? So there are 20% transactions where both of those products were bought together. Is that clear? So far, so good. Let's say who can give me the answer for the remaining 2. Support for milk, bread and butter, and beer and diaper. Hmm? 1 by 5 for which one? Milk, bread and butter. Milk, bread and butter. Only one transaction over here, milk, bread and butter. So 20%. And beer and diaper? Beer and diaper is 20%. Only one transaction where the beer and diaper was bought, right? By the way, there's a story, beer and diaper, that you can look up. I mean, it's like, more like a story only. It's not really this one, but you can read this story, right? So people who bought beer would be buying the diaper, and it was like against all intuition. Why would somebody who buys beer will buy the diaper and vice versa, right? It just throws you completely off, right? Right. So, so you can, yeah. So there's many ways of explaining that, right? So you can read that. I'm not gonna go there, but so how Walmart used to use data to sell more diapers and beer, right? Some of this is fact, some of this is fictional, right? So, but the main idea is that dad is stuck at home and all of that, and he basically goes and says, okay, what I'm gonna do sitting at home, I might pick up some beer also, right? And all of those things. So that's where this becomes really relevant when you want to do the product placement, what we call as a planogram, right? So this is very important in the retail world. How many of you have some retail background? You have, yeah. So like this, which products getting placed to which one, right? All of those things. So the items which are frequently bought together should be together, right? Why would you like somebody to like, so if you keep toothbrush in one end and toothpaste in the other end, I mean, that's just it doesn't even make sense. Oh yes, 100%. I mean, they're like, hundreds of engineers working in Target for just doing this in Manyata Tech Park, just to figure out what the placement should be, right? So because I was there. So I mean, planogram is a huge thing. I mean, they'll figure out what placement, what should be the on the upper aisle versus the like this upper rack versus the middle rack. You can tell more on them. All of those placements are really important, right? What should be on the aisle right after this? Like, I mean, right behind, what should be the product after that, right? So all of those things. So it's very, very like, all science driven, and that's where this really comes in, right? But there is counter to it as well. So sometimes they will say people come in for milk in my store. Milk they will not keep in the front, they'll keep in the back. So you have to go all the way, check out all the products, and then pick up the milk, and while you're picking up the milk you'll pick up something else, right? So that's irrational since I'm here. So there is a lot of science that goes, you follow this and you say, okay, I'm going to do a counter strategy as well, right? So but that's the bottom line. So support is clear, people. Now comes a little bit more tricky one, which is the confidence. Confidence is where the probability comes in. How many of you are really strong in probability? Raise your hand. Only 1%. Okay. So conditional probability, have you guys heard in the statistics class? What is a conditional probability? Yes. If something has happened, then the odds of the other event changes, right? That's what basically this is, conditional probability, right? So the way you're going to read that is, what is the confidence that the right hand side will be happening given that left hand side has already happened? Or the other way in the statistical terms is, what will be the probability of the hmm? Event A and B and all of that. So, but I think there is another term that I was going to come to. Antecedents and consequence. Antecedents are something which have already happened. Consequence are something which are going to happen after that. Consequence, right? Antecedents meaning some event which has already happened, then consequent, what is the probability that event to be happening, right? So the way you're going to read is, what is the probability that consequent, which is the right hand side, will be happening given the antecedent has already happened, right? Or what is the probability right hand side will be happening given the left hand side has already happened? And if you expand on the conditional probability, which is nothing but the support of right hand side, left hand side divided by the support of left hand side. That's what basically it boils down to. So how are you going to read this? What is the probability that a customer will buy milk given that they have already bought the bread and butter? Right. So when I say given that they have already bought the bread and butter, it's not like that you have to chase the customer after they have done the, like, the billing. You know that they have put something in their cart, and in your e-cart also, like, in your e-commerce websites, they have put something in their cart, then immediately you're recommending, okay, by the way, did you forget this one, right? And all of those things. So what is the probability milk will be bought given the bread and butter has been bought? So that will be nothing but support of right hand side, which is milk, and left hand side, which is bread, butter, and milk, divided by the support of left hand side, which is the bread and butter. So who can tell me the math? What is the numerator over here? Yeah, but what is the numerator? Numerator and then denominator. So numerator is nothing but support of left and right hand side. So how many transactions where bread, butter, and milk, all three were bought together? 1/5. So numerator becomes 1/5. What is the support for left hand side where bread and butter were bought together? Bread and butter, 1/5. So that's 100%. So, like, if somebody has already bought bread and butter, there is 100% likelihood that they will buy the milk as well. Does that make sense? So that's how basically you're going to interpret this, right? Now let's see who can give me the next one for beer and diaper. What is the probability somebody will buy beer given that they have bought diaper? 1/5 by 1/5. Correct? Everybody's agreeing? Okay. So now you can see how support and confidence are tying to each other. Support meaning how many transactions follow this? There could be only one transaction that follows that. And confidence meaning if that has happened, if that one transaction has that behavior, then what is the probability that I can recommend certain things, right? So that's what basically it is. So ideally would like to have a high confidence and high support, right? So that you can make the right product recommendation. So you can figure out the rest of them. So let's just do maybe one more. Who can do the fast math? What is the probability somebody will buy butter given they have bought milk? 50%? 1 by 5 by 2 by 5. So 50%. Everybody's with me? Yeah. So I think that number will be this number only, 1 by 5 by 2 by 5. Yeah. Okay. Lift is interesting. So lift, the third parameter, lift is in terms of something that we know as a cannibalization. Does anyone know what is a cannibalization, Anupam? What? Yeah. So when one product sale eats another product sale. So when somebody has bought something, they will be less likely to buy the other product, or when they are not complementary, right? So for example, let's say somebody has already bought, I don't know, let's say 300-liter refrigerator. How stupid will be to recommend another 300-liter refrigerator from another vendor, right? So they are cannibalizing. So I mean, if they have already bought, then they will not be buying this. So lift basically captures that. It captures whether the events are independent or they are complementing each other, right? So it's basically the A union B divided by support of A times B. And A union B, people who are aware, if two independents are completely independent, then this is nothing but the probability of event A times the probability of event B, right? So if they're completely independent, then the lift will be one, that they do not affect each other at all. If they are against each other, then the lift will go below one. So if something has been bought, then the other product will not be bought, right? In terms of that. And if the lift is more than one, then it means they are complementary. So you should be selling them together. So far what you've learned is that in conviction and everything, I'm leaving here for now. So far we have learned is the volume is important. How many transactions follow that? Confidence is important, that if I recommend this, what is the probability somebody will be buying this? And then lift is important, that lift should be at least one for us to really have the right sort of product bundling done together so that they're not eating each other, right? So with that, what I can do is I can just show you how you will be building this, and then you can go ahead and start building on your own. So this is again made up data. So this is not a real data. So don't worry, how simple this data is. So, but this is something which is quite realistic in terms of, how the scalability will be. So I have some transaction IDs, and then I have what was the product one, what was the product two, and what was the product three. And it doesn't mean that the product one will be the first product that they are buying. It just means basically stock keeping units, SKU or SKU as we call them. Anupam, you can keep me honest. SKU, right? Or what? SKUs, SKUs. So that doesn't mean that this product will always be the first product that we are buying. It just means that the SKU for this product is one. SKU for this product is, sorry, the product assortment category I'm looking at, then the different SKUs will be applicable for these products, right? So let's just do a quick one and look into what are the different things. So you have bread, fruits, juice, nachos, and all of those things. And then you have other things like butter, jam, salsa, vegetables. And then you have dairy, egg, and salad, and all of those things, correct? So what we want to see is if somebody has already bought this broad product category of one, what in the product category two they will be buying, what in the product category three they will be buying, and vice versa. And they can start with the product category three also, right? So let's go and look into this. So the very first thing we are doing over here, people, and maybe I can do this so that I'll share the notes. So just hold on a second. Yeah, so very first thing we're gonna do is following. We'll be not looking at um, the normal way of doing the dummy coding. What we really want over here is this function, which is get dummies, right? And what the get dummies do is basically it will say, just like what we were looking at the data earlier on. So, you know, you have a transaction 0, 1, 2, 3, 4, all these transactions are there. And it will say whether this product one bread was there or not. One means that was there. 0 means it was not there. All of those things. So for each of these products, so it's going to expand the number of columns to, like, you know, whatever number of categories, whatever number of labels that you have in those categories, it's just going to blow up like this horizontally. And it's important because we just want to know whether that product was there, yes or no, right? We don't want to know how many volumes were there. So for example, whether somebody bought one bread or they bought 15 bread, that is not there. We just want to know whether they bought the bread or not along with that. Is that clear so far? And that's coming in from something called as get dummies. I think you guys have already done that. So this is a method in pandas, coming in from pandas, right? So it's just basically instead of using that dummy coding, we'll be using this dummy coding. So then let's go ahead and look into this. So once you have this data frame, so you can see my original data frame was, I didn't do it, but 2000 rows, 2000 rows. So this was original data frame was 2000 rows and how many columns, anyone? 3 columns. When you do this get dummies, it becomes 2000 rows and 11 columns because of this expansion. Is everyone clear on this? Okay. Now the very first thing that we're gonna do is we will call in this module called a priori, and a priori is coming in from this package called ML extend. And if you're running on your local system, you will need to install this. It will not be installed by default. It's a heavy package, but if you're running it in the collab, this will be there, right? So in your Anaconda, you have to install. So don't forget that because this is part of your assignment also. In your Anaconda, you have to install ML extend, otherwise it will not be running, right? So if you're in collab, you're good to go. So ML extend, we are importing a priori and association rules. Is everything clear so far? Because we'll not be running this just in interest of time. I'll be assuming you can run it at home. So the first thing we're going to do is using that a priori. I am passing on my df1. What is a df1? Df1 is nothing but this 2011, right? So this I'm passing on over here, and I have defined the min support is equal to 5%. 5% support as minimum. What does it mean? That we want only those transactions, those rules, which are happening at least 5%, not 50%, at least 5% of the time. So if it is not less than, not more, if it is less than 5%, we're not interested to know those rules. So only show me those transactions which are happening at least 5%, right? So it's a sizable volume that we're looking at. Is everything clear so far? And then we say, then you're going to build the association rules and we'll use this data frame which has been created. So we will pass on this data frame over here. And metric is lift. Remember the lift we spoke about, that lift less than 1 means cannibalization, more than 1 meaning complementary, and 1 meaning they are independent. So we are saying at least show me those rules where the lift is 1. Minimum threshold is 1. You can have any higher lift which is there. That's okay. So what are the rules that you're looking at? So minimum support of 5% and minimum lift of 1. So these two things are there. You can give me those rules, right? Because I just don't want to look at all the 100 rules which are not making sense. So that's what it came out, and it says, okay, fine, I have your rules ready for you. So it came out with these 70 rules, right? And what are these 70 rules telling you? Antecedent, meaning what? This is the prior. Consequent meaning post. So antecedent and consequent. So if somebody has bought the butter, what is the probability or what is the, I mean, shall I recommend them bread or not? Is basically what this rule is saying. So it says, yes, you can recommend them. Why you can recommend them? Because it says that the antecedent support is 24.65%. What does it mean? Antecedent support is this? No, support. Remember, this is support. Yes. So 24.6% of the times butter is there in the transaction. And it is only looking at the antecedent support. So keep in mind, it has antecedent support. What is antecedent? Butter. So there are 24% transactions where butter has been bought. So that's a good number, like almost 1/4 transactions have butter in it, right? So, and then similarly, you have a consequent support. Consequent support meaning 35% of the transactions in the overall transactions have bread in it, right? So this is the bread which is there. And then there is a support for this rule. What does it mean? Support for butter and, so this basically corresponds to, this rule corresponds to butter plus bread both together, not separately. Sorry, this rule, my bad. This rule. So I'll erase that because I'll save it. Yeah. So this rule says butter and bread both have been bought 21% of the times, which is again great rule to have, right? So far with me? Now, so that was the support. Now let's look into something different. Confidence. Confidence is 87%. What does it mean? Yes. So if I look at all the people who began their journey, so let's say there are 100 people who bought butter as the product one. Out of those 100 people, 87 people went in and they bought bread as well. So the confidence that if I have person X walking in and they have already done the butter in their basket, there is 80% probability that they would also pick up bread. So why don't we go ahead and make that recommendation to them? Right. So that's what basically it boils down to. Right. And then that's about the confidence. And it says, there are 20% people or 20% transactions which show the same behavior when somebody has bought in terms of the volume. So the support, this is for the volume. And this confidence is for the likelihood. Likelihood, right? I mean, the spelling you can make out. And then lift is positive and everything. So all of that is there. So that's what basically this boils down to, right? Is this clear concept-wise, people? And then you can do the sorting. So I can do the sorting of like, what are the, let's say I don't want to make 70 recommendations. I want to make maybe top 5 recommendations, right? So you can sort it. So I'm saying, sort by the support and confidence and lift, right? So you can see, these are the guys where your support is the highest. So I'm sorting by the confidence. And then within that, then I'm sorting by the support, then the confidence, and then lift, and so on and so forth. And it gives you really good rules that you can work on in different tables. So that's how basically it is done. And you can define your cutoffs as well. So for example, over here, I'm saying I only want those rules where lift is more than 2, confidence is more than 60%, and support is more than 20%. So these are your, how many rules? 1, 2, 3, 4, 5, 6, 7, 8 rules which follow that criteria. Is that clear? Which criteria? That your lift is more than or equal to 2, plus your confidence is more than or equal to 60%, and your support is more than or equal to 20%. So these are the rules which are coming in, right? Is that clear? Yeah, but you must have this, no, antecedent and consequence as well. So you must have, like, different product categories. You can do a conditional thing there. Yeah, definitely. You can do a conditional thing. If I'm coming in from this, like, city or area, and I have this blood sugar level, I think there was one very popular database that you can study. It's called the Pima Indians. Have you guys heard about this Pima Indians? So look up this database, right? So this is a very good classic case study. So this is a, like, town in Mexico where they were very healthy. Their ancestors were very, very healthy. Very, very healthy. Nobody had diabetes at all in this entire village, right? But then, since the people, Westerners came in, they started eating cheese and all the, like, junk products and everything. So they already had a predisposition in their genes that if they not eat healthy, they are very, very likely to become diabetic, right? So, but that catalyst was missing all this time because they were eating this like millets and red meats and all those things. They were not eating, like, high, fat content and stuff like that, right? But once that ingredient got mixed in, then suddenly that exploded. And like every second person is a diabetic there in that town now, right now. So you can look up this Pima Indian. That will give you that answer. So it's all conditional things. So it's not absolute. So certain things in certain geography will work. Other things, Pima Indians diabetes data set, right? And there is a good YouTube video that you can watch that will take you in terms of, how this, you'll get the entire history. No, I think this is the building of the model. But it's a good documentary that you should watch. Pima Indian diabetes documentary. No, that's not it either. Anyways, you can see. I mean, you can look up. I think you'll one of you will find and you can share. I think this is the one. Nope. Anyways, you can dig up. So that's the bottom line. So now let's come to your assignment part, which you will be submitting. So what are the assignments for today, folks? One is, yeah. So let's talk about your assignments for today. And which is this example right here. So this is the third assignment. So you will go to this data set. So this is your assignment number 4, or no, I mean for today. So let's call it, today is the fourth class, but we've done 3 assignments so far, right? So we will call it 3C maybe, the third component of today's assignment, which is the MBA. And what you have to do is to use this data set called, from here, University of California at Irvine, there is data set called online retail, right? And this has, this very interesting data set. So this is the actual data set, by the way. So this is a store and you can see what they have bought, how much they have bought. And what you have to do is you can filter on one country. So remember, if you grab all the countries, this will be a humongous data to take one country only from this data, one country only. So you can choose Italy, you can choose UK, you can choose France. It's all European countries, right? Australia is also there. Choose one country and do this entire rule that we are doing. So I think in this case, I'm choosing Italy, and you can see how we are going and building some of the rules over here. So this is what you're going to submit as your 3C. What is the 3B? 3B is your K-means. K-means on heart disease. And what was the 3A? Random forest on your favorite Titanic data. No, just Titanic is fine. Yeah. So these are the 3 assignments for today. So that's what you need to submit, right? And then we are done. So next class is the last class, people. So besides all the excitement for the quiz, we're gonna cover following things. What are the things we're gonna cover? Time series modeling. So 45, 46. We'll cover the lasso and the ridge regression. We'll just talk about the concept at a high level. We will definitely cover principal component PCA, and then we will cover the auto glue on somewhere over here, but the link is not valid, so ignore that. I'll just walk you through. And then, yeah, this link is not valid. So I think it just basically takes you somewhere. So I'll try to update that so you can read. So this one, auto glue on, time series modeling. And yes, I mean, I don't have the link for it. It's the other thing we're going to cover is model explainability. Right? Particularly some of the things like a SHAP or line and other things. So that's what we're going to cover. So this is the 5th class, last class. The module will be, and I'll share this note with you, model explainability, then time series, PCA. What else did we speak about? Yeah, ridge, lasso, elastic. And then we'll have your quiz. Yeah, quiz will be 25 questions, 5 minutes. We can do any time, but most likely it will be towards the end once you've done the time series and everything. So you know what those concepts are, right? And then we'll do the auto glue on. And then we will leave you for better things that you want to do on 14th of February. So that's the plan. I'm done for today. Any questions, thoughts before we wrap up? Is that all? Okay. Thank you, everyone. Let me just save it and then I'll share with you. Yeah. Yeah, I will. But I think somehow this didn't save all the writing. What? Sorry, which one? It's there in the UCI machine learning. UCI machine.